Hello everyone, my name is Dhruv Jetpa and this is the channel Codeology, but now we are going to do something apart from coding. This is a thought that I got. I've been very interested in design thinking, so I've been doing that since childhood. So I got an idea for perpetual motion. So please look into it, and if this works, the world will be a completely different place to live, a much better place. So let's get started. So imagine there are just a second. Yeah, imagine there are four magnets. One, two, three, not to be scaled. Four. Okay, now these are the four magnets. Now we'll name them A, B, C, and D. Alright. Now what we'll do is we'll have a permanent magnet here. Here we'll have a permanent magnet, wherein this is the north pole and this is the south pole, as you can clearly see. Now what we will do is these four magnets A, B, C and D are not stationary. They can rotate 180 degrees at a time. So if you can see clearly, they can rotate 180 degrees at a time. So this can also rotate 180 degrees. Same for this. And same for this. Direction doesn't matter here. Or for the four magnets, 180 degrees. Okay. Now what we'll do is we will be mapping. We'll create a table here. Where is my pen? Yeah, right here. We'll create a table and we'll be mapping the values for A, B, C and D. You'll get to know what I mean. So basically this is A, this is B, this is C and this is D, and these are the values. Alright, now we'll break this in 1, 2, 3 parts. Okay, so if I take this a bit ahead, this is time step 1, this is time step 2, this is time step 3. Alright, so now what we'll do is initial configuration will be north, north, south, south. So our initial configuration is north, north, south, south. So at timestamp 1, in what direction will the motor rotate? So I am covering this part. So in what direction will the motor rotate? If this is north, north, south, north, north, south, south. Since these two will be repelling this and this will be attracting this, and same for this. These two will be repelling this and this north pole will be attracting this. So it will create a clockwise motion of 90 degrees. So the magnet will be like this. The north pole will be here and the south will be here. Now to make it rotate again 90 degrees, what we'll do is we'll switch the polarity of B and D. So B is north, will make it south, D is south, will make it north. So the A and C will remain the same. So now what is it? N, S, S, N. This is already N, this is S, this is also already S, and this is N. So resulting this and looking at the horizontal configuration, the magnet will rotate 90 degrees again. Same thing we'll do now. We'll switch the polarity of A and C. Now the north is at the bottom of the magnet and south is at the top. Now we'll do with A and C. South and C will be north, south and north. So it will rotate clockwise 90 degrees again. So what I mean by this is if we keep changing this configurations, basically there are four cases. Or for the central magnet, if we see, there are four main cases. One is where this is the case, north and south. Another is this is the case, north, south. Another one is this is the case, north, south. And the last one is this, north, 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 yeah. And the last one would be north and south, right? So these are the four cases: north, south, south, north, south, north, north, south. Basically the time steps. Ignore that. This is a very important video. I'm shooting it ad hoc, so please be with me. So in this situation, if the north is on the top, south is on the bottom, and this is the configuration, the magnet will rotate 90 degrees clockwise. For this configuration at time 2, this will rotate clockwise 90 degrees. For T3, this will rotate clockwise 90 degrees. And the same will happen for T4. So that is the idea, and the question is, how will we change the polarity of these magnets? So basically, if I were to draw A would look something like this. Here there is A, so A would be like this. Yeah, this is north, this is south, initial position. What we'll do is, after every rotation of this big magnet, the bar magnet, once it rotates 360 degrees, or let's say if every 90 degree that it rotates, not 360, 90 degree that it rotates, the magnets opposite to the poles have to rotate by 180 degree. So this is 90 degree and these two will be rotating at 180 degrees. Basically the key is just rotate the magnets opposite to the central magnet by 180. So when it is horizontal, we'll do this. When it is again vertical, we'll do the same. So that is the thing. So 190 and 180, right? So the radius of this circle, so basically if I were to mark the radius, this length, if it is r, then for every r rotation, the opposite magnet to the position has to rotate by 2r. So this can be very much possible with gears. So I leave it to the mechanical people, and even I am brainstorming on it as to how to first rotate these two, then these two, then these two, then these two. So which will keep this rotating. So please give me your inputs on this. Please comment. Please make this idea successful. We'll do it together. So thank you so much, and please let me know the inputs.